Welcome back. Question 4. You're told that given that k is a positive constant and the integral from k to 2k over 12 over x squared plus 4 with respect to x is equals to 14. So find the possible values of k. So number 1, we are given the integral from k to 2k over 12 over x squared plus 4 with respect to dx equals to 14. So if you look at this, we're going to integrate. So this one can also be written as the integral from k to 2k over 12x power negative 2 plus 4x with respect to x equals to 14. Now we can integrate this. Of course, when integrating, we just increase the power by 1 and multiply by the new power. So that means we'll have negative 12 x raised to negative 1, of course, plus 4x, then from k to 2k to be equals to 14. And remember, we can still write this as negative 12 over x plus 4x from k to 2k to be equals to 14. But the second part will be substituting or replacing x with the starting from 2k, then subtracting when x equals to k. So if we do that, then this is what we're going to have. We're going to have negative 12 over 2k plus 4 into 2k. So this is the first one, minus when x equals to k, we'll also have 12. So negative 12 over k plus 4 into k, and this one should be equals to 14. Then simplifying further, we will have negative 6 over k plus 8k, of course the first bracket, minus. In this case, we'll have negative 12 over k plus 4k, and this one equals to 14. So what we can do, we can remove the brackets so that we remain with negative 6 over k plus 8k plus 12 over k minus 4k, and this one should be equals to 14. Collecting the like terms where possible, we can have in this case negative 6 over k should be added to 12 over k, then plus 8k minus 4k, this one equals to 14. So the denominators are the same, so we can simply subtract the numerators. Negative 6 plus 12 is equivalent to 6, so we'll have 6 over k plus 8k minus 4k is simply 4k equals to 14. And what we can do at this point, we can multiply everything by k. So that means if at all we multiply everything by k, so this one we can multiply by k, by k, by k, so that what we are going to have is 6 plus this is 4k squared equals to 14k, and this one can be rewritten as 4k squared, of course, minus 14k, then plus 6 equivalent to 0. So what we can do, we can factorize, because 4k squared, negative 14k, and 6k, there's a common factor here, which is 2. So we can divide through by 2, and therefore we'll have 4k squared divided by 2 minus 14k divided by 2 plus 6 over 2 equals to 0 over 2. And this gives you 2k squared minus 7k plus 3 equals to 0, which is a simplified quadratic equation. We can use quadratic formula, completing square method, or we can use product sum rule, and I will want us to use product sum rule. So what we have here, the middle term, we have negative 7k, so we'll be looking for two numbers whose sum is negative 7, and the product is simply 2 times 3, which is 6. So the factors in question can be, we can have the factors negative 6, negative 1. So what I will want us to do, negative 7k, we can split it so that what we'll be having, 2k squared minus 6k minus k plus 3 equals to 0. Then we can factorize the first two terms by grouping and the last two terms by grouping. So what is common between 2k squared and negative 6k? So in this case 2k is common, so we'll factorize out 2k, so we'll have 2k into 2k goes here, k times, then 2k goes here, minus 3. Between negative k and positive 3, the common factor in this case is negative 1, which will give us k minus 3, and this equals to 0. So this means that either 2k minus 1 or k minus 3 is equivalent to 0. Setting each bracket to 0, we'll have 2k minus 1 equals to 0, and therefore 2k equals to 1, and k should be equals to a half, or k minus 3 equals to 0, and therefore k should be equals to 3. So we have the two values of k equals to half, or k equals to 3 as your final solution.